On January 7th, David Bennett woke up just like he had every day before. However, this day was slightly different because he had a new heart. Mr. Bennett was waking up from the first successful surgery in which a pig heart was transplanted into a human. Most of us don't have to think about organ transplants that often, which is probably a good thing. However, transplants have become an integral part of medical science in the 21st century. According to the website for the United Network for Organ Sharing, last accessed October 8th, 2022, almost 30,000 organ transplants have already taken place in the United States just this year. These procedures have given new opportunities to patients both young and old whose conditions were previously seen as being untreatable. Mr. Bennett's story is particularly noteworthy because this procedure was the culmination of decades of research on cross-species transplantation, otherwise known as xenotransplantation. Xenotransplantation is on the verge of revolutionizing medical science, so it's important that we understand this complex process by first looking at how humans started to use animal products in medical settings, then looking at how years of work have resulted in modern xenotransplantation procedures, most of which involve porcine or pig components. Finally, we will look to the future and attempt to predict how all of this will be applied in the years to come. Xenotransplantation isn't as new as some may guess. In fact, the first procedures involving animal components took place all the way back in France in 1667, according to a 2017 article from the Smithsonian Magazine. The medical pioneer in question here was Jean-Baptiste Denis, the personal physician to King Louis XIV. Denis transplanted lamb blood into 4 young men, 2 of which died very shortly after their procedures. Their families accused Denis of murder, and such procedures were banned in France, as well as becoming medical taboo for the next few centuries. Explorations into xenotransplantation picked up again in the mid-20th century when doctors began to realize that the reason for so many previous failures was that the human immune system was rejecting the foreign organs. According to a February 2022 article from the Association of American Medical Colleges, immunosuppressive drugs were eventually used when transplanting primate livers, kidneys, and hearts into humans. These patients had the chance of surviving anywhere from just 2 hours to several months after their procedure. Then, as explained in a February 2022 statement from the NYU Langone Transplant Institution, porcine or pig organs started to replace primate organs in transplant research. This is because pig organs are more similar in size to human ones. Also, due to having more genetic differences from humans than other primates do, pig organs are less likely to transfer diseases during these procedures, making their long-term success more likely. Now that we've looked at xenotransplantation from its earliest applications, we're ready to dive into the modern work being done with porcine organs. Modern procedures involving porcine components have had increasingly successful results that cause doctors to have an optimistic outlook on the future of xenotransplantation. An article published in 2016 in the Journal of Tissue Engineering discusses the effectiveness of using porcine acellular lung matrix in healing damaged tissue in rats. Cellular matrices are mesh-like patches that surgeons use when they're finishing a procedure. The matrix acts as a helping hand for the afflicted area by supporting the growth of new cells. The goal for the procedure, using the porcine matrix in rats, was to imitate how currently used matrices aid the healing process in humans. Standard cellular matrices are made with human skin tissue, and the only difference in the pig one is that it's made from a pig's lung membrane. At the end of the study, the researchers concluded that the porcine matrix had more cellular density and grew more blood vessels than the human one did, both of which are ideal qualities of a cellular matrix. Another modern medical innovation involving porcine components is porcine fibrin sealant. Fibrin sealant is a liquid that is applied to wounds after injury. It's meant to act as a glue that speeds up the healing process. A June 2022 article from the Journal of Evidence-Based Complementary and Alternative Medicine describes an experiment in which porcine fibrin sealant was used to treat wounds in rats and was shown to speed up the healing process more so than traditional medical sealant does. The future of xenotransplantation became increasingly bright when doctors were successful in transplanting the first pig heart into the aforementioned David Bennett in January 2022. NBC News wrote an article describing his story in July 2022. The procedure went smoothly, and Mr. Bennett was able to survive with the pig heart for 2 more months before eventually passing away. His cause of death is one of the biggest takeaways from this medical venture. Mr. Bennett died because his body was ultimately too weak and the porcine heart failed. However, his body didn't reject the foreign heart, and it was successful in extending his life in the face of chronic heart failure. Since his body didn't reject the porcine heart, the researchers considered the procedure a success, which means that porcine xenotransplantation is not only medically viable, but also that it has the potential to change medicine forever. We've looked at the past experimentation in xenotransplantation and what's being done with it today. So now, let's look to the future and analyze how all of this work could be applied in the years to come. Current research in xenotransplantation can be seen as an investment in the humans of the future because it could be the key to solving a huge problem in the medical field, a shortage of donor organs, especially kidneys. According to organdonor.gov, last access September 25th, 2022, there were 90,483 patients on the waiting list for a kidney transplant in 2021. Only 27,670, or about 27%, of these individuals actually received a transplant. Also in 2021, researchers at the University of Alabama at Birmingham successfully transplanted pig kidneys into brain-dead humans. According to an article from the Scientific American, these kidneys were able to perform their vital functions for an extended period of time, which implies that xenotransplantation could meet the demand for kidneys that will inevitably be greater in the future. Furthermore, a February 2022 article from the New England Journal of Medicine suggests that the current techniques being used to prepare animals for xenotransplantation procedures can be applied to other parts of medical science. Currently, these animals are being genetically modified in a way that reduces the risk of aversive effects from cross-species transplants by making it harder for the recipient's body to recognize that the new organ is actually from a different species. This makes the rejection of the foreign organ much less likely. After the positive results of David Bennett's procedure, many scientists are optimistic that these genetic techniques could be applied to other areas, such as stem cell transplants. A release from the Mayo Clinic in July 2022 explains how animal stem cells can be genetically modified and then transplanted into humans to aid in the regeneration of damaged tissue. This application of stem cell technology, plus the reduced chance of organ rejection and the possibility of having a more vast source of donor organs, means that xenotransplantation truly is capable of changing the medical field for good. From early experimentation in animal blood transfusions to a man surviving with a porcine heart, xenotransplantation has undoubtedly progressed in leaps and bounds since its beginning. Today, we explored how xenotransplantation was first pursued by humans with only few victories for multiple centuries, then how we began to make tangible improvements in this area with procedures involving porcine components, and how all of this research could be applied in the future. Thanks to patients like David Bennett, the use of porcine and other animals' organs is becoming increasingly normalized in the medical field and will save countless lives in the future.